In this video, we're going to learn how to convert equations from polar form to rectangular coordinates form. We're going to start with this equation. Let's suppose that we need to convert r equal to 5 secant of theta. Okay, so we're going to use the same equations that we know from the previous video. So we know that x, it's equal to r cosine of theta, and that y is equal to r sine of theta. So if we're going back to x and y form, we need to have something similar to this to be able to convert it to x, and we need to have something similar to this to be able to convert it to y. All right, so we know that secant is the reciprocal of cosine. So we can rewrite this as r is equal to 5 times 1 cosine of theta. Remember that this is an identity. So now that we have this, we notice that if we get rid of cosine and we're able to multiply by r, we will have precisely this, right? And the only way that we know to do this is apply the inverse here. So we multiply by cosine of theta on both sides. So cosine of theta, right? And we know that this will cancel out, and we know that cosine of theta times r is the same as r cosine of theta, equal to 5 times 1, that is 5. So now we have r cosine of theta, but r cosine of theta is equal to x, so we can substitute this expression by x, so x will be equal to 5. All right, so this equation, this polar equation will be written as a rectangular equation in this form. X is equal to 5. Okay, let's do another one. Okay, so let's try to convert r. It's equal to 2 sine of theta. In this case, it's going to be really difficult to imagine that if we convert this using an identity, then we'll be able to have something like this, right? But we can notice that the only thing that is missing to this sine of theta is this r to be able to substitute it by y. So we can multiply on both sides by r, right? We multiply both sides by r to be able to have this expression. So r times r is r squared. So this will be equal to 2 times r sine of theta. I'm just reorganizing the information. All right, so we know that r sine of theta is equal to y, so we can substitute that by, so we have r squared is equal to 2 times y, right? But we also know from previous studies, we know that r squared, the radius squared, is going to be equal to x squared plus y squared. So we can substitute r squared by this. So we know that this r squared can be substituted by this. So x squared, okay, let me rewrite it, x squared plus y squared will be equal to 2y, right? And if we isolate everything, so we have x squared plus y squared minus 2y equal to 0, right? We have this equation we can complete because if we already study conics, we know that this is pretty similar to a circle. This is pretty similar to a circle. So we can complete the square, right? Remember that we complete the square taking this 2, right? Taking that 2, divided by 2, and square it. So 2 divided by 2 is 1. 1 to the power of 2 is 1. So if we add 1 on both sides, we know that we are completing the square. If we are completing the square, this trinomial can be written as y minus 1 to the power of 2. Remember, we find the square root of this. The square root of y to the power of 2 is y, and the square root of 1 is 1, and we use this symbol. So y minus 1 to the power of 2 will be the factor form of that trinomial. And we cannot forget about x, so we have x squared plus this, the square of this binomial, and it's going to be equal to 0 plus 1, that is 1. So this is the equation of a circle. This is the equation of a circle. If we graph it, it's going to be a circle with center 0, 1, right? If we want to graph this, then we will have something pretty similar to this. I'm going to publish another video in which I'm going to explain how to graph this kind of equations. But for now, if this is 1, right, this is 1, we're going to have a circle pretty similar to this. I'm going to do my best to draw the circle, right? All right, something like that. So I'm going to have this circle, right, with radius 1. This is -1. This will be like the graph of my equation. This is not the point of this video, but it's just like a heads up. All right, let's do another equation. Let's convert this equation. R, it's equal to 2 plus 2 cosine of theta. So we are in the same condition as in the previous equation, right? We will need to have an R being multiplied by this cosine, right? So if we multiply R on both sides, so we multiply R, we multiply all this expression by R. You can do it like this, or probably you remember this from algebra, you multiply by this, right? So you multiply here and you multiply by the second term also. So R times R is going to be R squared. So R squared is going to be equal to 2R plus 2 times R cosine of theta. I'm just reorganizing. Okay, and we know that this, it's equal to x, so we can change it by x. So R squared is going to be equal to 2 times R plus 2x, right? But we'll still have this and this R, but we know that we can change this by this expression because R squared, it can be substituted by x2 plus y2 equal to 2R plus 2x, right? We can isolate this 2R. So if this is adding, then we need to subtract on both sides by 2x, if you remember, right? And this 2 will cross out, and we will have x2 plus y2 minus 2x is equal to 2R, right? And now, how do we get rid of this R? You can imagine that, all right, so if I have R squared again, I can substitute it, right? So if you try to multiply on both sides again, then you're doing basically nothing, right? So the answer is not multiply by 2. The answer will be that we can elevate both sides to the power of 2, right? To the power of 2. Let me write that 2 properly, 2, right? So if we do that, and let me rewrite it here, if we do that, we will have all this is in a power. So we have x2 plus y2 minus 2x to the power of 2 will be equal to 2 to the power of 2 is 4. R to the power of 2 will be R to the power of 2. And now we can change this by this expression again. So we will have x2 plus y2 minus 2x, everything to the power of 2 equal to 4 times x2 plus y2. So this is basically the equation, and you can say like, hey, this looks way too complicated. It's more complicated than what we have before. This one, the previous one. Let me erase this arts for a second, right? It looks way more complicated than all this, right? And that might be true, but we are able to deal with this equation and be able to graph it as our rectangular coordinate. Let's do something more simple maybe. What if we try to convert the next equation? So we have R equal to sine of 2 theta. You probably remember that this is an identity, right? This is an identity that it's called the double angle identity for sine. And you know that this is equal to, R is equal to 2 times sine of theta times cosine of theta. You can substitute this expression by this identity, right? And you can do the same analysis as we did before. What am I missing here to have these two things, right? And what I'm missing is an R here, right? So I can multiply by an R here and an R here, right? So I can multiply an R by cosine and an R by sine. If I'm multiplying R and R, it means that I'm multiplied by R2, and I need to do it on the left side of the equation to like balance it out, right? So R2 times R will be R3, R to the power of 3. That is equal to 2 times R sine of theta. But we know that R sine of theta is Y, so 2Y. And we know that R cosine of theta is X, so times X, right? But also, if we isolate R r is equal to the square root of x2 plus y2, right? So I can substitute r by the square root of x2 plus y2 to the power of 3. That is equal to 2xy, right? We can even rewrite this, if you want, as x2. Let me do it here. x2 plus y2 to the power of 3 over 2, if you remember the notation for fractional, for rational exponents. And this will be equal to 2xy, right? Or, in other words, we can also rewrite it using this exponent on the other side. That will be 2 over 3. Okay, that's how you deal with this type of problems. So I think that this is enough to get a hold on how to use the previous formulas that we learned to convert equations from polar form to rectangular form. So see you in the next video.